Ever wondered what happens when you give a twist to a simple strip of paper and join the ends together? Welcome to the fascinating world of the Möbius strip, a curious geometric anomaly that dwells in the realm of three-dimensional space. This strip, named after the German mathematician August Ferdinand Möbius, is more than just an intriguing party trick. It's a mind-bending concept that challenges our understanding of traditional geometry and the nature of space itself. With just a single twist, an ordinary strip of paper transforms into a peculiar object with only one side and one edge. Yes, you heard that right. A side that is both inside and outside. An edge that is both top and bottom. This video will take you on a journey through the intriguing mathematical properties of the Möbius strip, its geometric features, and its construction. Get ready to dive into the world of Möbius strips, where reality defies common intuition. Creating a Möbius strip is surprisingly simple, yet it unravels complex mathematical principles. Now, let's dive into the process and witness the magic of mathematics in action. To start off, all we need is a strip of paper. Yes, that's it, just a simple, ordinary strip of paper. You can pick any strip of paper, the one from your notepad, a cutout from a newspaper, or even a piece of ribbon, as long as it's long and slender. Now hold the strip by its ends. You'll notice that it has two sides and two edges, just like any other strip of paper, but we're about to transform it into something extraordinary. Next, give your strip a half twist. Yes, just one half twist. Now instead of the ends of the strip being parallel to each other, you'll notice that one end is now upside down relative to the other. Interesting, isn't it? But here's where the magic happens. Join the two ends of the strip together. You can use some tape or glue to secure the ends, and just like that, you've transformed your ordinary strip of paper into a Möbius strip, an object with just one side and one edge. Take a moment to let that sink in. Go ahead, run your finger along the surface of the strip. You'll find that you can trace the entire surface starting from any point without ever lifting your finger. That's because our little twist has transformed this strip into a single-sided object. And what about the edges? Well, just as you trace the surface, you can also trace the entire edge of the strip without ever lifting your finger, confirming that it indeed has a single edge. And voila! You have just created a Möbius strip, a marvel of mathematical topology. This simple experiment, believe it or not, is a window into the complex and fascinating world of mathematics. So the next time you see a strip of paper, remember, it's not just a strip, it's a potential Möbius strip waiting to be discovered. The Möbius strip is a conundrum. It challenges our basic understanding of geometry. It's a shape that's so simple yet so complex, it continues to fascinate and perplex mathematicians and geometry enthusiasts alike. The Möbius strip, named after the German mathematician August Ferdinand Möbius, is an intriguing geometric figure. But what sets it apart? Two primary features, its single-sidedness and single-edgedness. What do these terms mean, you ask? Let's delve a bit deeper. The single-sidedness of the Möbius strip is a phenomenon that defies our usual understanding of surfaces. Imagine you're an ant crawling on the surface of a Möbius strip. You'd find that you could crawl from one side of the strip to the other without ever crossing an edge. In other words, the strip has only one continuous surface. Now let's talk about the single-edgedness. Just like our imaginary ant that could traverse the Möbius strip without crossing an edge, a line drawn along the edge of the strip would return to its starting point without ever crossing an edge. This is because the Möbius strip has only one edge, not two, as our intuition might suggest. These features challenge the very foundations of traditional geometry, where a surface is usually defined by its two distinct sides, and an object typically has multiple edges. But the Möbius strip, with its single surface and single edge, stands as a stark contrast to these norms. A point to note, however, is that these unique features of the Möbius strip are only possible because it exists in three dimensions. If we were to try to create a Möbius strip in two dimensions, we would quickly find that it's simply not possible. The strip requires that extra dimension to twist and connect in a way that results in its unique properties. The Möbius strip, a paradoxical object, defies our basic understanding of geometry. It's a testament to the beauty and complexity of mathematics, reminding us that sometimes reality can be stranger and more fascinating than fiction. Beyond its intriguing geometry, the Möbius strip also possesses some fascinating mathematical properties. One of the most striking properties of the Möbius strip is its non-orientability. In simpler terms, this means it doesn't have two distinct sides as a regular sheet of paper does. You can start drawing a line on one side and end up back where you started without ever lifting your pen, having covered what seems like two sides. This property has profound implications in the field of topology, a branch of mathematics concerned with the properties of space that are preserved under continuous transformations. This single-sidedness of the Möbius strip challenges our conventional understanding of dimensionality. It is a two-dimensional object, yet it behaves as if it's one-dimensional due to its single-sidedness. This strange behavior leads us to another mathematical property of the Möbius strip. Its boundary is a simple closed curve. If you trace around the edge of the Möbius strip, you'll end up back at your starting point, having traversed the entire boundary once. The Möbius strip has also found its way into various mathematical proofs and concepts. For instance, it's used to illustrate the concept of a compact surface, a term used in topology to describe shapes that are finite and without any holes. Despite its simplicity, the Möbius strip serves as a powerful tool for understanding complex mathematical concepts. The Möbius strip is a beautiful demonstration of the unexpected and the strange in mathematics. It's a simple object, just a strip of paper twisted and joined at the ends. Yet, it has properties that defy our intuition and stretch our understanding. It's a reminder that mathematics isn't just about numbers and equations, but also about shapes, spaces, and their surprising properties. The Möbius strip is not just a mathematical novelty, but a testament to the beauty and depth of mathematical exploration. The Möbius strip is not just a mathematical curiosity, it has real-world applications too. This might surprise you, but this quirky, one-sided object has found its way into various fields, making the most of its unique properties. Let's start with the world of engineering. Ever notice that some conveyor belts seem to last longer than others? Well, there's a good chance that the long-lasting ones are designed using the Möbius strip concept. By giving the belt a half twist before joining the ends, the wear and tear gets distributed evenly across both surfaces of the belt, effectively doubling its lifespan. Brilliant, right? Now let's move on to the realm of electronics. Compact electronic circuits are often designed with the Möbius strip in mind. Here's why. The strip's unique one-sided surface allows for a continuous pathway for the electric current, eliminating the need for the circuit to cross over itself. This results in a more compact design, which is particularly useful in devices where space is at a premium. But it's not just in the world of practical applications that the Möbius strip shines. It also inspires and challenges artists and architects. Some artists use the Möbius strip to create intriguing sculptures that play with our perceptions of space and form. Similarly, architects incorporate the Möbius strip's unique geometry into their designs, creating buildings and structures that are visually striking and structurally innovative. The Möbius strip even finds its way into the field of magic and illusion. Magicians exploit the strip's one-sided property to perform tricks that seem to defy logic and leave audiences astounded. So the next time you see a magician perform a seemingly impossible trick, remember the Möbius strip. The Möbius strip, a mathematical marvel, finds its place in our everyday world, proving that math is not just abstract but practical and fascinating. So the next time you come across a Möbius strip, appreciate it not just as a mathematical curiosity, but as a tool that's shaping the world around us. What started as a simple strip of paper has led us on an extraordinary mathematical journey. We've seen how a mere twist and a tape can birth the intriguing Möbius strip, a one-sided surface defying our conventional understanding of geometry. Its bizarre features, like the single continuous edge, have left us both intrigued and baffled. We dive deep into the mathematical realm, exploring fascinating properties that challenge the norms. The Möbius strip, with its non-orientability and inherent paradoxes, has proven to be a delightful conundrum for mathematicians around the globe. Then we ventured into the real world, witnessing the Möbius strip in action. From the infinite loop in conveyor belts to the continuous surface in electronic components, this mathematical marvel has found numerous practical applications. The Möbius strip, a testament to the beauty of mathematics, invites us all to look beyond the obvious and explore the fascinating world of mathematical topology.